All right, today we are going to talk about a different form than slope-intercept form. So we're going to open up with this question. We are on page 15 and 16 in our notes. Again, you probably will need your calculator, and so it's called point-slope form. And so we're going to open up with this question. Leo knows that the slope of a line is -4, and the line passes through the ordered pair -7, 18. Without doing any calculations, can Leo easily write an equation for the slope for the line in slope-intercept form? Why or why not? Record your thoughts in the bubble at right. So go ahead and just take a second, write down what you guys think, pause it if you need to, and then when you're ready and you have your thoughts down, hit unpause. Okay, so for my first instinct, when I think about slope-intercept form, y equals mx plus b, okay, I think about how I have the slope of a line and I have the starting point or the y-intercept of a line. And with the information that Leo has, he does have the slope. He knows that the slope is -4. And then he has this ordered pair -7, 18. Well, that is not telling me where this line starts or where it crosses the y-intercept, because your b value is where it crosses the y-axis, or when x is 0, and this is not when x is 0. So I cannot, without doing some sort of calculation, figure out how to write this in slope-intercept form. Okay, so when that something happens, there are many ways we could figure out what the slope or what the y-intercept is, and one way is using a totally different form. Okay, so this form is called point-slope form. And it is another equation for a line that can be written easily when you know the slope of the line, so the rate of change, and you have a point on the line that is not the y-intercept. Okay? So in this instance, we have our slope, which we label as m, and a point on the line, we would label it as x1 and y1. Okay? So this is the form. You don't have to have it memorized. It'll always be available for you. Eventually, you guys will probably get used to seeing it. Okay, so your m is your slope. Okay, and when we actually substitute in the values, this will be a number. Okay, x1 is the x-coordinate of the ordered pair that they tell us. So again, this will be a value when we actually have an equation. And y1 is the y-coordinate of the ordered pair. So again, this will be a actual value. So the only thing that will maintain, well, there will still be an x in the equation, okay, just like how mx plus b has x, and it'll still have a y, like y equals has in slope-intercept form. Okay, so let's first just practice understanding this equation. Okay, so we have a line that crosses through 8, 3, and it has a slope of 1/4. So what I'm going to do is I'm going to write this formula, write this form, and instead of my y1, my m, and my x1, I'm going to use these values. So my slope is 1/4. Okay, this is my x-coordinate, and this is my y-coordinate. So that kind of helps me a little bit. So my equation will be y minus y1, so 3, equals m 1/4, parentheses, x minus x1, which is 8. Okay, so this is in slope-intercept form. So actually we could just stop there. We will practice simplifying this into slope-intercept form, but this is what all we're practicing right now. Okay, number 2, we have -6, +12. So that's a point that goes on through this line, and it has a slope of -2. So again, this is my x1 and this is my y1. Okay, so my equation will be y minus 12, okay, equals m, parentheses, okay, x minus, and I have this -6. Okay, another way that we could write this is whenever we see this subtracting a -6, I will actually just write, I'll say x minus, and so then if I see a -6, I will just change that to addition, and then the 6. Because subtracting a negative is the same thing as adding. So eventually when we feel better with this, this is the more simplified version. All right, number 3, this one crosses through -2, -11, and it has a slope of 5/2. Okay, again, this is my x coordinate. This is my y coordinate that goes through the line. So using this form, y minus, and again, minus a -11, I could just write minus a -11 and just create an addition problem. And m parentheses x minus x1, so -2. All right, for this final one, we have our m, we have our x coordinate, and we have our y coordinate. So y minus y1 equals m times x minus x1. Question 5 says, explain how your equations were affected by the sign of the ordered pair values, positives or negatives. Okay, so for this one, we had 2 positives, so they stayed a subtraction problem. This one, we had a negative value, so it actually became an addition problem. This one, there was a positive, so it was still a subtraction problem. Okay, so we can say something like, when ordered pairs are positive, we will see subtraction, because that is what the formula has. It has a subtraction problem. But if they are negative, then we would have minus a negative value, which is the same thing like adding a positive. All right, so for each of these equations in point slope form, we are going to label what the slope is telling us and what a point on the line is. All right, so again, if you want, you could just write the form right on top of it and then just do some matching. Okay, so my slope is my m, is my m value. Okay, so that looks like it is right there. Okay, so I'm going to write my slope being -7. Okay, then I'm looking for my x coordinate. So I see an x1 being 3 and y1 being 2. Again, the formula has subtraction in it, so I see subtraction, so I can just write 3, 2. All right, for the next problem, y minus y1 equals m times x minus x1. Okay, I can just first just identify. Okay, and then I can just write it down. So my slope is 9/4. Okay, my point is x1. So again, it has the matching subtraction, so I can just write 3. Then this one is y1. So again, I see a minus, but in the equation, it has plus. So this would have to be a -8 for it to match and make an addition problem. All right, for this last problem, we have a slope of -2/3. Okay. And that's pretty simple to see, just matching. This is +9, so when we write our ordered pair, we'd have to flip it, and it'd have to be a -9. And then our y1, we see a +6, so again, we would have to flip it to a -6. All right, number 9, a graphed line has the equation y + 1 equals -8 parentheses x minus 2. Camden and Drew agree the slope is -8. Camden thinks the line passes through the point -2, 1, while Drew thinks the line passes through to -1. Who do you agree with? Explain. Okay, so I'm going to write the form. Okay, and then I'm going to write the equation that they have underneath it. Okay. Again, they agree that the slope is -8. Okay, so we just need to figure out what the correct point on the line is. So I see subtraction. So I see a positive 2. Okay. And then I see addition. So I need to flip it to a negative 1 for my y coordinate. So I agree with Drew. Okay, so on page 15, now we're actually going to write some equations. So to write an equation in slope-intercept form, given 2 points, first use the slope formula. When we learned the slope formula, we could do y2 minus y1 over x2 minus x1. We could also find our slope by just finding the change over the change. I think most people like the change over the change more. Okay, then what we'll have to do is we'll have to substitute the slope and the values from one of our ordered pairs into the point slope equation. Okay, so Mrs. Bernice asked her students to find the equation of the line that passes through -2, 4, and 422. So the first thing, no matter what, we have to find the slope. Okay, so if you like to do the slope formula, you could do y2 minus y1. Okay, or you could just ask yourself, how do you go from 4 to 22? And the answer is 18. Okay. And then you could also use the formula and do 4 minus -2. Or you could ask yourself, how do you go from -2 to +4? And you get 6. Okay. And so 18 to 6 is the slope ratio. We can simplify 18 to 6 equivalent to 3. So the slope of these two ordered pairs is 3 to 1 or just 3. Now what we're going to do is you can pick either point. We're going to do both of them at the very beginning. Okay? And we are going to substitute them into our point slope equation. So first we're going to do -2, 4. Okay, I'm going to write the equation real quick. Y equals y minus y1 equals m times x minus x1. Okay, so my equation would look something like y minus 4, because that's my y value, equals 3, because that's my slope, parentheses, x minus -2. So again, I made an addition problem. All right, for this other ordered pair, okay, we're just going to do the same thing, but with this ordered pair. So y minus y1 equals m. So our slope is 3, parentheses, x minus x1. Okay, so then part C says to rewrite each equation in slope-intercept form. So what we're going to do now is we're just going to go back to this and make it look like y equals mx plus b, because that's what we usually feel most comfortable with. Okay, so we're going to distribute the 3 and get 3x plus 6. We're going to add 4, and we get 3x plus 10. Okay, for this equation, we are going to distribute the 3 and get 3x minus 12. Then we add the 22, and we get y equals 3x plus 10. Right. So one thing that we notice is that it has the same equation. And so what that means is it doesn't matter if you use this ordered pair or if you use this ordered pair, they will still give you the equivalent equation if we actually wanted to graph this in slope-intercept form or simplify it down to slope-intercept form. Okay. So these two questions, it asks to write the equation that passes through the points in point slope form. Then rewrite the equation in slope-intercept form. Okay, so the first thing, no matter what, just what it says, is first we have to find the slope. Okay, so I'm just going to find the change in the change. Okay, so to get from -5 to -3, I would have to add 2. So my change in my y values is a positive 2. Okay. Then to get from 8 to 12, I would have to add 4. So the change in my x's is 4. So my rate of change is 2 to 4 or 1 to 2. So that is my slope. Okay, so now I'm about halfway there. Okay. Now I have to pick one of these 2 points, just like what we just talked about. It doesn't matter which ones you pick. So I always look for an easier one. These are both pretty similar. They both have a negative. So I'm just going to go with the smaller number. It doesn't really matter. Okay. So I'm going to write this in point slope form. So y minus y1, so minus -5 would become plus 5, equals 1/2 times x minus x1. So that is in point slope form. Okay. Now to put it into slope intercept form, we would just simplify and solve for y. So we get 1/2 x, half of 8 is 4 or -4. And again, if you guys feel comfortable, you guys could do this in your head. So y equals 1/2 x minus 9. And that is the equation in slope intercept form. All right. For this equation, for these 2 points, we have 218 and 644. So we want to first write it in point slope form and then slope intercept form. So I'm going to find the slope first. Okay, to get from 18 to 44, I'm going to do 44 minus 18, so I get 26, so I have to add 26. So that's the change in my y values. And then to get from 2 to 6, I would have to add 4. Okay. So slope, we want to keep it as a ratio if we can. So I'm just going to simplify this to 13 over 4. Okay. You could make it a decimal 16.5, but usually we like it to have whole number ratios. So I'm just going to say that the slope is 13 to 4. Okay. So now for our point, again, you can pick either one. I'm going to pick this one just because it's smaller. It still would get the same answer. So y minus y1 equals our slope times x minus x1. Then to put it into slope intercept form, we would have to distribute 13 over 4x. So 13 over 4x times -2 is -13. And then I would have to add 18. So y equals 13 over 4x. -13 plus 18 is 5. So y equals 13 over 4x plus 5. So that's how we can use point slope form to find the slope and then to find it in slope intercept form. Okay, write an equation for the relationship in each table in either point slope form or slope intercept form. Discuss why you chose the form that you did. Okay, so it wants us to write an equation. We could write it in slope intercept form, or we could write it in point slope form. This is the new form that we have been introduced to. Okay, no matter what, we still have to find the slope. Okay, so I'm going to find the slope for number 13. Again, you can pick any points that you want. I'm going to use numbers that are friendly, so I'm going to use these ones because I don't want to deal with decimals. So the change in the y's, to go from -8 to -7, the change in the y's would be up 1. Okay. The change in the x, to go from 0 to 4, would be up 4. So the slope is 1/4. Okay. Now, when I think about slope intercept form, I have a slope and I have the starting point. When I think about point slope form, I just need the slope and I need any other point. Okay? So I just need to basically ask myself, do I know the starting point or would I have to calculate it? So when I look at this, I actually see the starting point. The starting point is when x is 0. Okay? So I know what the starting point is. The starting point is at -8. So why not just write it in slope intercept form? Okay, so in slope intercept form, it'd be y equals 1/4 x minus 8. And we chose that because we knew the b value, because that is when x is 0. So we know the y-intercept. right, for number 14, again, we have a table. First, no matter what, we need to find the slope. So the change in the y's. To go from -1 to -16, we'd have to go down 15. To go from 5 to 10, we would have to go up 5. So the change over the change would be down 15 for every time we go up 5, which would be equivalent to -3. So our rate of change is -3 to 1, or just -3. Okay. So again, what I'm asking myself is, do I know the starting point, or would I have to calculate it? So when I look at my x values, I don't know the starting point. So I'm going to use point slope because I don't know from the table what the starting point would be. Okay, so you can pick any of these. It does not matter. I'm just going to pick the first one because it's the smallest. Okay, but again, you could pick any of them. Okay, so my equation would look something like y minus y1, so y minus -1, so it becomes addition, equals the slope times x minus 5. Okay. If you look at this table, you can see they're going up by 5s. So if you have that intuition to just go back 5, that would be when x would be 0. Okay. Then if you know that these are going down by 15s, to go backwards, you could add 15 and get 14. Okay. So if we would actually do this, we should hopefully get a y-intercept of 14. So you could do that real quick. Just distribute the -3. -3 plus 15. And then I would have to take away the 1. And I do notice that I still get a y-intercept of positive 14. So that is kind of a good way if you guys just notice like the skip counting, you can go down to 0 easily. That would be a quick way to use slope intercept as well. So you don't always have to use point slope if you know that we need a starting point, and you could just follow the pattern back to 0. All right, so today there's going to be a Go formative that you guys can start. My suggestion would be to get as far as you guys can and then come with any questions tomorrow for class, because in class you can work on that Go formative, but there will also be some Delta math questions that look very similar to these where you have to write them in point slope form. All right, I'll see you guys tomorrow.